Section 1 is all about writing linear equations. So the first one says, write an equation for the line that has a slope of m equals 1/4 and passes through the point -8, 1. Automatically looking at this, I know I need to write it in point slope form and slope intercept form. Always start with point slope form. You're given a point and a slope. Boom, you're done. Now remember, point slope form is y minus y sub 1 equals m times x minus x sub 1. I'm going to fill in my missing pieces. I've got my point here, my slope. I'm going to plug those in. Y minus 1, because that's my y coordinate, equals 1/4 x. Now it's minus a -8, so minus a negative turns into a plus sign, so that's a positive 8. Now from here, now that you've done this part, you don't know the intercepts, but from point slope form, you can just solve for y to get slope intercept form. So this is my answer for point slope. Now I'm going to go ahead and solve for y to put it into slope intercept form. So I have y minus 1 equals, I'm going to distribute my 1/4. So it equals 1/4 x plus 2. I always ask myself, what's a fourth of 8? Or I could say, another way to say it is 8 divided by 4. That gives me 2. Now I add 1 to both sides. And I'm left with y equals 1/4 x plus 3. So now I'm doing problem 2 the same way. I'm going to plug in my slope and my point into point slope form. Again, I have y. Now it's a plus 15 because minus this negative changes it into a positive, equals -2 times x minus 8. Done. That quick and easy. Plug in the pieces you know. Now I'm solving for y to get slope intercept form. So I got y plus 15 equals -2x plus -2 times -8 is a positive 16. Then I subtract 15 from both sides, subtract 15. It's finally solved for y, so I get y equals -2x plus 1. Problem 3 says we're still writing an equation, but instead of giving us a slope, it gives us 2 points. Well, we can find our slope given 2 points using our slope formula. Our slope formula, if you don't call that, is y2 minus y1 over x2 minus x1. That's m. So I'm going to find my slope using my 2 points. I'm going to say 9 minus 5 over -2. Now it's minus a -8, so I'm going to change that to a plus 8 equals 9 minus 5 is 4 over a positive 6, and that reduces down to 2 over 3. Then that's my slope. I take this and I pick one of the 2 points and plug it into point slope form. I'm going to pick -8, 5. So I've got y minus 5 equals 2/3 x plus 8. Again, it's minus a negative, so I change it to a plus sign. There's part A. Part B, solve for y now. Distribute your 2/3, add 5 to both sides, and you can get that. So y minus 5 equals 2/3 x plus, when I multiply fractions, I multiply straight across, so it becomes 16, because I can put a 1 there, over 3. Then I add 5, and I get y equals 2/3 x plus 31 over 3. Just add that on your calculator. I'm not worried about a mixed number. So So on page 2, section 2, it says graphs of linear equations. The directions tell us to write an equation for the graph, and that you may write this equation in point-slope form or slope-intercept form. Now, I do want to remind you all that this portion of the test will be multiple choice. But for the sake of practicing and getting better at this, I want you to write those equations on the pretest. So I'm going to look at question 4 here. The first thing I'm going to start with doing is finding the slope. In either equation, point slope, slope intercept, you need to find the slope. Well, right here, it perfectly crosses these 2 points. So I'm going to count the rise and the run. It looks like it rises 1, 2, 3, and runs 1, 2, 3. So that's m equals 3 over 3. However, we are stellar algebra students, so we write that as 1. That's our slope. Now, is there a y-intercept on here? Does it cross this y-axis? Yes, it does at -3. That's going to be my b. So since we have a slope and an intercept, let's put it into slope-intercept form. Y equals x minus 3, because we know we have the imaginary 1 here. And you're done. So I'm doing the same thing for problem number 5. I'm always going to start when I see a line to find an equation for it. I want to find the slope of that line. So again, it crosses right here and right here. Those are 2 nice points we can count. I see that it rises 3 and runs 3. That looks very similar to the one before. So I know 3 over 3 is the same thing as 1. And we can see that down here, because if I go from this point to this point, it rises 1, runs 1. Now, does this have a y-intercept? I'm going to go to my y-axis, and look, it crosses right here at +3. So my b is 3. Then I take my y equals mx plus b, and I plug in the m, and I plug in the b. Y equals 1x plus 3. And we're done. So when I'm, again, trying to find my equations of my lines, I'm always asking, what's the slope? If I use point slope or slope intercept, either way, I always need a slope. So I've got 2 nice points here. And I'm going to find the rise. I'm going up 1, 2, 3. And to the left, 1, 2, 3. But I noticed that the number 6 graph is going the opposite direction of 5 and 6. So I'm going to say, okay, here, what does slope dude say? He would say, nice negative. So I'm plugging in that negative out front. Now, remember, 3 over 3, we write it as 1. So m equals -1. Then again, for the 3rd time, I'm asking myself, what is my y-intercept? So I go on my y-axis, and I see where it crosses. Crosses right here at +3. So my b is 3. And then I plug it into slope-intercept form. Y equals negative. I'm not going to write my 1 because we could just write x. We don't need to write -1x. You can, it's not wrong. Plus my 3. Section 3 is all about parallel and perpendicular lines. So for question 7, it tells us to write an equation in slope-intercept form for the line that passes through the point -8, 5 and is parallel to the line y equals 2x plus 11. Now, there's 2 ways to do this. I can take my slope, take my point, plug it into point slope, or I can say see a point slope and just use my slope intercept. I am going to say by point slope and only stick with my slope intercept form. I know I need to use my slope of 2, and for my new line it's going to stay 2 because slopes for parallel lines are the same. So m equals 2. And I know it needs to go through this point. So based off the information I have, if I were to write this equation right now, I would have y equals 2x plus b. But I don't know my y-intercept. So to do that, I'm going to use my point they gave me, and I'm going to plug that information in for y and x, then solve for b. So I have 5 equals 2 times negative 8 plus b. That becomes 5 equals negative 16 plus b. Then I add 16 to both sides, add 16, and my b equals 21. I take this information, I take the 21, plug it in over here for b to get my final equation for this parallel line to be y equals 2x plus 21. Then you're done. You're going to go ahead and you're going to do the exact same thing for 8, the exact same process, but you just need to make sure that you're using your opposite reciprocal slope because this is a perpendicular line. So I'm going to look at the equation they gave me, and that's y equals 3x plus or minus 15, and that slope is 3. But for my new line, I need the opposite reciprocal of this, so the opposite is going to be negative because it's a positive, and then the reciprocal of 3 is going to be 1/3. Now I'm going to use this information over here, and I'm going to go right away into writing it like this. So I'm going to have negative 7 equals negative 1/3 times 4 minus or plus b. And I'm going to solve for b. Negative 7 equals negative 4/3 plus b. Add 4/3. Add 4/3. That gives me b equals negative 17 over 3. Remember, don't freak out about the adding fractions to whole numbers. You're going to get a calculator on the test. Just use your calculator. Then your final equation is y equals negative 1/3 x minus 17 over 3. What I did on this second problem is I skipped some of the setup of question 7. And then problem 9, it says find the slopes of lines A parallel and B perpendicular to the graph of the equation. So I'm just worried about what those slopes are if I found the slope for a parallel line and for a perpendicular line. Now, looking at this, I see the equation here is in standard form. So I can't right away recognize what that slope is. So I'm going to take this and I'm going to put it into slope-intercept form. I'm going to solve it for y. So I have 6x plus 21y equals 14. I want y by itself, so I'm going to subtract 6x first. Then I'm going to write this in mx plus b form, and I have 21y equals negative 6x plus 14. I can switch these around using the commutative property. Then I take my y and my 21y and divide it by 21 because I just want to know what y equals. And I do the same thing over here. That leaves me with y equals negative 6x over 21 plus 14 over 21. But I look at that and I go, that's ugly. I know that it can be simplified more because all of these can be reduced. So this becomes y equals 21 and 6 have a greatest common factor of 3. So that becomes negative 2 over 7x plus 14 and 21 have a GCF of 7. So that becomes 2 over 3. Then this equation, the slope for this is negative 2 over 7. So if I have a parallel line, I'm going to keep it the same. And if I have a perpendicular line, I'm going to say it's the opposite, so it's going to be positive, and the reciprocal. So your answer for that slope is 7/2. Section 4 is all about inverse linear functions. In class, we talked a lot about inverses and saying we switched them, their opposites, things like that. So to find the inverse function, you take your x and y and you change them, and then you solve for your y again. So I know in this equation here on 10, g of x here is the same as saying y. So my equation is y equals 3x plus 7. Now to find the inverse, so over here I'm going to find the inverse. So we write it in function notation like this. I'm going to say x equals 3y plus 7. And this is what we did that circle puzzle on. Now I just solve for y. So I minus 7, I'm left with x minus 7 equals 3y. I divide by 3, divide this entire side by 3, and that answer is g, put it up to the negative first power of x, because I just want to go ahead and write it in function notation right away. It's the same as saying this new y over here is equal to that. Then I divide x in 3. Now remember there's an imaginary 1 here. So it becomes 1/3 x minus, because I have a negative divided by a positive here, minus 7/3. So in problem 11, we're doing the same thing. Now, instead of writing all this extra work like I did up here, so I'm going to go ahead right away and exchange my x and y, and I'm going to say x equals 1/2 y minus 3. Now I solve for y. Add 3 to both sides. Add 3 to both sides. I'm going to rewrite that over here. And that's going to be x plus 3 equals 1/2 y. Now, we would look at this and we say, okay, it's 1/2 times y. But dividing by fractions is such a pain. You got to keep, change, flip, and all that work. When instead, I want to cancel that 2, so I'm going to multiply this by 2. And then I'm going to multiply this entire side by 2, because you can't leave the x or the 3 hanging. You got to multiply both of them by 2. So that gives us 2x plus 6 equals, my 2's cancel, and that leaves me with y. And then I'm going to write this in function notation. So I have the inverse of x equals 2x plus 6. And there you're done. So then 12, it asks us to write the inverse of relation A. So I'm going to call our inverse, I'm going to call that relation B. Now, for this, when we have a set of ordered pairs, we're just exchanging our x coordinates and our y coordinates. So for my first pair, it becomes 5, 3. My second ordered pair becomes 0, 6. I'm exchanging the x coordinate and the y coordinate. My third one becomes negative 3, 2. And my last one becomes 4, 5. Still putting it in that set notation. Then I've got my last section here, the key concepts. What was this unit all about? My goal for these questions is for them to be easy, free points. So 13 says, the slope-intercept form of the equation of a line is, that's y equals mx plus b, where m is the slope and b is the y-intercept. We took a quiz over this. I don't know how many times I've said this, but if I had $1 for every time I went through that, I'd probably be a millionaire. Then I've got 14. The point-slope form of the equation of a line is, this is what I did on the very first page, is y minus y sub 1, signifying that coordinate, equals m times x minus x sub 1, signifying that x coordinate. Where our point, it says blank is a point, so I'm going to call that x sub 1, y sub 1. That's my point that I would plug into my point slope. And again, m is the slope. Then I've got question 15 and 16, which we spent a solid week on it. And that's where we're talking about parallel and perpendicular lines and all about their slopes. So what is unique about the slopes of lines that are parallel? Well, if I looked at those equations, I would know that their slopes, specifically about their slopes, is that they both have the same slope. Then on question 16, it says, what's unique about the slopes of lines that are perpendicular? Well, that's where they're opposite reciprocals. Not opposites or reciprocals, they're opposites and reciprocals of each other.